Good evening, and thank you everyone for joining us for IGI Global's 2018 webinar, How Does Big Data Affect You? A look into the process that drives everyone's decisions, featuring Dr. Richard Segal of Arkansas State University. While everyone gets settled in, I would like to take this time to tell everyone about IGI Global. IGI Global has been a leading academic publisher for 30 years, with an ever-expanding portfolio of 4,500 reference books, over 175 highly indexed journals, and a broad collection of InfoSci databases. IGI Global is committed to providing the highest quality publications, excellent service, and a steadfast pledge to the research community and underrepresented research. IGI Global publishes in 11 different subjects, including business and management, computer science and information technology, education, engineering, environmental, agricultural, and physical sciences, government and law, library and information sciences, media and communications, medical, healthcare and life sciences, security and forensics, and social sciences and humanities. Today's webinar will be recorded, and all attendees will be sent a recording of the presentation after the webinar. Also, be sure to stay to the end of the presentation for a special giveaway for all attendees. Additionally, attendees will have an opportunity to participate in a live Q&A session with Dr. Segal at the end of the presentation. And you can enter questions using the chat feature located in the bottom of your GoToWebinar control panel. Feel free to type in questions as we go, and we will address them at the end of the presentation. Now, I would like to introduce our presenter, Dr. Richard Segal. Richard Segal is a professor of computer and information technology in the College of Business at Arkansas State University in Jonesboro, and also teaches in the Master of Engineering Management program in College of Agriculture, Engineering and Technology. He received his PhD in Operations Research from the University of Massachusetts at Amherst, served on the faculty of Texas Tech University, University of Louisville, University of New Hampshire, University of Massachusetts Lowell, and West Virginia University. His research interests include data mining, text mining, web mining, database management, big data, and mathematical modeling. Dr. Segal is a member of the Arkansas Center for Plant Power Production and on the editorial board of the International Journal of Data Mining, Modeling and Management, and International Journal of Data Science, and served as local arrangements chair of the Mid-South Computational Biology and Bioinformatics Society conference that was hosted at Arkansas State University. His research has been funded by National Research Council, U.S. Air Force, National Aeronautic and Space Administration, Arkansas Biosciences Institute, and Arkansas Science and Technology Authority. He is the recipient of several Session Best Paper Awards at World Multi-Conference on Systemics, Cybernetics, and Informatics conferences. He is the co-editor of 2 other books published by IGI Global, Visual Analytics and Interactive Technologies, Data, Text, and Web Mining Applications in 2011, and Research and Applications in Global Supercomputing in 2015. Dr. Segal is a recipient of Arkansas State University College of Business Faculty Award for Excellence in Research in 2015. Now, I will hand it off to Dr. Richard Segal.
Okay, the title of my webinar today is How Does Big Data Affect You? A look into the technological processes that drives everyone's decisions. And this accumulated in this 2-volume handbook, Big Data Storage and Visualization Techniques. And I'm honored to be the featured title in Computer Science and Information Technology for 2018-2019 of IGI Global. There were 85 books in that category, and we were honored to be the one and only featured title for this sub-area of Computer Science and Information Technology. I'm a professor in Arkansas State University, Neil Griffin College of Business, as I was indicated, and my contact information is on this slide. And if you look on the right side of the 2-volume handbook, you see this picture of big data. And, it encompasses a lot of different things, the structure of the data, the volume of the data, the analysis of the data, text analytics, the framework, and so forth. So it's really a whole realm that's led to this 2-volume handbook. And so the outline of the webinar today is, I'm going to talk a little bit about what's in the first 2 chapters of the book. And the first chapter relates to what is big data. And the second chapter is, how can we store big data? And thirdly, how can we visualize big data? and then I'll talk about the contents of the entire handbook of big data storage and visualization techniques by Segal and Cook, which was published by IGI Global in 2018. And then we have an open question and answer session. Okay, so what is big data? Big data is a term for data sets that are so large or complex that traditional data processing applications are inadequate. I teach an undergraduate class in database management. We talk about the relational database model. But when we get to millions of rows of data and so forth, we need new techniques and new models, and how to work with this type of data. And this leads to many different challenges, which includes how do you analyze the data, how do you capture the data, how do you curate the data, how do you search the data, how do you share it, how do you store it, transfer it, how do you visualize it, how do you query it, update it, and information privacy of the data. So the big data characteristics are many. We're talking about dimensionalities of data of the yoga byte, and which we'll talk about, and which is way beyond what a byte of data and so forth. But we have different types. The data characteristics. What kind of data is it? Is it streaming data, which is these arrows down here? Streaming data. Is it real-time data, or is it batch processing? And what's the structure of the data? Is it unstructured, semi-structured, structured, or whatever? And we have different characteristics of this data that we have here of volume, velocity, and variety. And so we'll talk about that a little bit later. But the volume of the data. So we can have data from various different sources. From business transactions, social media information, from machine to machine data. What is it? What's the size of this data? And the velocity of the data. Is it data streaming? Is it which means it's continuously flowing data? Or what's the variety of the data? Is it a mixture of these structured numerical data? Is it email? Is it video, audio, stock data, etc.? So here we have a table of data measurements. And if you look at the bottom there of yogabyte, there's actually 27 zeros following the one on the traditional method there on the third column there. And if you look at the exact measurement, that's pretty precise. The 1, 208, etc., 925 on the bottom there. How do you accurately be able to count all that data? Or in the traditional method, it's just rounded off. So and if we have data, we really have to account for all the data. We just can't estimate what we have there. Okay, so why big data? The key enablers and areas of the growth of big data are, we need to be concerned about the increase of storage capacities, and that's what this book talks about. The title of the book is Handbook of Big Data Storage and Visualization Techniques. So how do we store this data, and how do we visualize it? So, so we need an increase of processing power in order to store it. We need to have the availability of the data. Every day we create 2.5 quintillion bytes of data, and 90% of the data in the world today has already been created in the last 2 years alone. And so we have the 3 V's of big data, as we indicated here, and variety, volume, and velocity. And I said variety. Is it the data could be, some of it could be structured, some of it could be unstructured, some could be semi-structured, or it could be all of those together simultaneously. And the volume of the data, terabytes of data, records, transactions, tables, velocity of the data. Is it batch data, real-time streaming data, near-time data? How do we deal with all these types of data and so forth, whatever it is here? So, like a company like Amazon.com, they have so much data. They're opening up 2 new warehouses, and we're talking about there has to be methods to deal with that. So the question, or the problem is that we can have big data and so forth. So it's not really about the size of the data; it's about the value of the data. But how do you get the value within the data? You can't get value within the data unless you know how to visualize it, how to use it, how to store it, and that's what this whole book talks about. So That's all the challenge, a lot of challenges that we have. And so there are many awesome ways um, in which big data is used to change our world, and such as understanding and targeting the customers. Um, a lot of these places, like the supermarket, will give you these uh, cards that they scan when at the checkout. They're just checking to see what your buying patterns are and so forth. So they're understanding your buying patterns and so forth. And and like retailers such as Target, how do they accurately predict what the customers will want when they for what they need and so forth. And so telecommunication companies can now better predict customer churn, and Walmart can predict what products will sell. Car insurance companies can understand how well their customers actually, how much they actually drive, and so forth. And this big data analytics is also used in the elections and so forth. How do they deal with this big data? I mean, we get a problem right now in the recounts of the state of Florida, and how can we actually record big data? And so for improving and optimizing. Let's go back here. Um, Business processes, uh, supply chain and so forth. Um, in manufacturing and so forth, General Motors, they have so much data that they have for all their parts and components. Uh, how do they integrate all this big data together? Retailers, they need to know what they need for the predictions and so forth. Weather forecasting, um, whatever. The third one there, personal quantification, performance optimization. We have all these smart watches and smart bracelets and so forth that are now wearable devices, and that it's in the collecting data for this, for all the people that purchase these and so forth. And so, um, some of these companies are collecting personal data on your activities levels and sleep patterns and so forth, and uh, they're trying to quantify or make some assessment of that. Improving healthcare and public health. We can decode the entire DNA structure in minutes and allow to find new cures for better understanding and predicting disease patterns. And microarray databases, which is actually a smaller dimensionality of DNA. How do you do data mining of microarray databases? And the data is just so intense. In a small microchip, you have an immense amount of data. And improving sports performance using video analytics to track the performance of every player in a football or baseball game. Improving science and technology. Um, you know, we have we have data centers. There's the Swiss Nuclear Physics Lab that has 65,000 processors, and it analyzes 30 petabytes of data and so forth. Optimizing machine and device performance, Google self-driving vehicles, improving security in law enforcement to detect, prevent cyber attacks. Credit card companies use big data to detect fraudulent transactions. Then we have improving and optimizing cities and countries. Big data is used to improve many aspects of our cities and countries. For example, it allows cities to optimize traffic flows based on real-time traffic information, as well as social media and weather data. Also in financial trading, we have websites to make buy and sell decisions in split seconds. So this whole thing of the structure of big data, we have, as I said, we have real-time data, we have batch processing, and this on the right-hand side here, real-time data could be credit and market risks in banks, and some of these things that we go across three different dimensionalities: structured, semi-structured, and unstructured, such as markdown optimization, retail, event-based marketing, and financial services and telecom. But structured data in the bottom there, traditional data warehousing, is more structured and more batch processing. And data velocity, predictive maintenance in aerospace, data velocity, demand forecasting, and manufacturing. So we have this data streaming and so forth. And how do we deal with all that? So as I said before, big data isn't big if you know how to use it. And that's what this whole handbook talks about, all the different types of techniques that evolved, very recently, and for the different types of applications. And there's an immense amount of work that's been done very recently to handle these types of things. And so the basic methods of database management cannot be used for big data. Okay, so big data storage. How do we store data? And that's what half the handbook is on. The interfaces of components of big data. Here we have raw data and the data access connectors, such as queries, structured query languages. But you see across the top here on the bottom, batch analysis, real-time analysis, data storage, interactive querying, serving databases, web framework, visualization framework. So like for batch analysis, we have things like MapReduce, Hadoop, ScriptPig, real-time analytics, stream processing such as Storm, data storage, Hadoop distributed file systems, NoSQL, interactive querying, analytic SQL, Hive BigQuerying. And so the bottom line is my book, or this handbook, our handbook, talks about all of these things together. This whole realm, a universe of these different types of data that we have. So there's two types of data-intensive computer systems. One is high-performance computing, which has to do with supercomputers, and is in my introduction. I do have another IGI Global book, which was published about 2 or 3 years ago on handbook. I was research and applications in global supercomputing, and that all deals with one of the ways of dealing with big data. And high performance supercomputers have to deal with shared memory machines, distributing memory clusters, message passing interface, and so forth. And also there's several different types of storage patterns for big data. And some of these methods include the facade pattern and the lean pattern, the NoSQL pattern, and the polylit pattern. The facade pattern has to do with Hadoop distributed file systems, which serves as the intermittent facade for traditional data warehousing systems. Lean patterns are H-based, which are indexed using only one column family and only one column and unique row key. The NoSQL pattern is the traditional relational database management system, which was replaced by NoSQL alternatives to facilitate faster access and querying of big data. And the polyglot pattern is multiple types of storage mechanisms, such as combinations of relational database management systems, file systems, CMS, object-oriented database systems, NoSQL, and Hadoop data file systems, which coexist in an enterprise to solve the big data problem. And so we talk about storage mechanisms for big data. There's a table on the next slide here for the different types of file systems that we talk about, and we'll go with that shortly. But some of the database technology for big data includes key-valued databases, column-oriented databases, and document databases, and platform for nimble universe table storage, or peanuts. And key-value databases are constituted by simple data models, and data is stored corresponding to key values. Each key is unique, and customers may input queried values according to the keys. And so there's various different types of software that we'll talk about in a future slide here. And in column-oriented databases, the column-oriented databases store and process data according to columns rather than rows. And the columns and rows are segmented in multiple nodes to realize expandability. Document databases are compared with key-value storage, and it can support more complex data forms. And since documents don't follow any strict modes, there's no need to conduct mode migration. And so we can use, in addition, key values can be saved with that. And so there's various software for that we'll talk about. And the platform for nimble universe table storage, or peanuts, is a large-scale parallel geographical distributed system for Yahoo's web applications. And it relies on simple relational data model in which data is organized into a property record table. Okay, so here we have a table of file systems for big data. And just some of the software that's out there, such as Azure Cosmos by Microsoft. Facebook has Haystack, Google File Systems, GFS, Tableau File Systems, TFS, Hadoop Distributed File System, HFDS, which we'll talk about later, which uses MapReduce as a key function for its data management. There's also Apache software. There's Apache Spark, which, when you have big data, one of the things Spark is scalability is a key benefit. Quantcast File Systems, QFS, Cluster. So this is just a subset of some of the softwares or file systems that I talk about in this handbook here. Okay, so some of the programming models that we talk about include that for MapReduce and Triad and All Pairs and Pragle and so forth. And these are all discussed in more depth in the following slides. Okay, so here we have some of the database technology for big data storage systems. Here's some. We have on the headings here. I have key value databases, column-oriented databases, document databases, platform-based databases, and here's just some of the software: Dynamo, Volumart, tokens, and so forth. But I can go on and on and on. And my handbook, our handbook here by Segal and Cook, has an immense amount of information about all of these key-based databases and so forth, database technology. And here we have programming models for big data. We have big data programming models such as All Pairs, Triad, MapReduce, Pragle, and the applications. MapReduce is used in genomic analysis. Pragle is used in network graphs. Triad is used in parallel processing of coarse-grained data. All Pairs is used in biometrics and bioinformatics. Some of the taxonomy of programming models: MapReduce. There's functional SQL-based and high-level languages here, software. So this is just a subset of, here we got 10 softwares here just in these 3 different categories of for these programming models for big data. And as I said, our handbook goes into a wealth of an encyclopedia of the other softwares and so forth. And so the categories of big data analytics. Big data analytics is a big buzzword right now, and so we have software that does data integration, data management, extract, load, and transform, warehousing, Hadoop systems, stream computing, which we have flowing data, continuously flowing data analytics, machine learning, content management, integration, data governance, and so forth. And so here we have a table of data generation requirements for different domains. And if you look in the first column, data generation, we can have design-oriented, we can have a discovery-oriented, we can have large centralized instruments, or we can have similar distributed instruments. And the visualization, which is in the last column there, for design-oriented, we're talking about feature display and so forth. Discovery-oriented with pattern detection, correlation, clustering. For large centralized, we're talking about visual analytics, trajectory analysis, user-driven data triangulation, summarization. Smaller distributed systems, we can talk about high-dimensional, large-scale graphs. And so, how do we storage these types of things? How do we transact? How do we overview? How do we share and distribute this? And so here's just, a table to show some of the distinctions between these. And so, we need to talk about how we store big data. So what are the file systems for big data? Okay, this table here shows file systems for big data: Azure, Cosmos, Facebook, Haystack, and so forth. Some of the characteristics again here: Azure was launched in May of 2017. That's not, that was last year. Facebook Haystack in April 2009 had 60 billion photos and 1.5 petabytes. That's almost 10 years ago. So it's a lot more than that now. Hadoop uses MapReduce as a function as data management system, and so forth. Quantcast file systems, produces over 80,000 transactions per second over 100 million websites. So this database technology that we're talking about here, here's some other ones here. I guess I talked about Dynamo, Volumart. These, column-oriented databases, document-oriented databases, platform-oriented based databases. This categorizes these softwares on that listed on the left there, as far as which of those categories they're with, and also the type of software that can work with that. Dynamo, platform-based databases, Peanuts, and so forth. And programming models for databases. All pairs uses Cartesian products. Dryad uses accurate graphs. MapReduce uses computational models such as MapReduce. Pragle uses Google-based that facilitates the processing of large-scale graphs. And so this taxonomy, again, of programming models, functional, SQL-based, high-level DSL, Pig Latin cascading, Trident. This handbook talks about these and a wealth of others as well as this whole universe here. Okay, here we have a list of the top 10 worldwide cloud storage systems for data-intensive computing using big data. And here we have ranked 1 to 10 the storage systems and the headquarters. And you notice that they're all headquartered in the United States. So these storage, number 1 is Amazon Web Services, which is currently their storage facilities are headquartered in Seattle, Washington. AT&T in Dallas. 3, Google Cloud Storage in Mountain View, California. 4, Hewlett Packard in Palo Alto, California. 5, IBM Smart Cloud Enterprise in Armonk, New York, etc. So these are the top 10 worldwide cloud storage systems. And as I said, supercomputing is, needs to be used for this, for the immense amount of storage that needs to be with this. Here we have characteristics of the top 10 big data storage tools, which are talked about in chapter 2 of this handbook here. And some of the data storage tools: Hitachi, Data Direct Networks, InfoGix, Nimble, and so forth. Nimble Storage, Predictive Flash, the last one dramatically improves performance of analytical applications and big data workloads. Number 3, Spectra Black Creel is an object storage interface to SAS-based disk. And Hitachi number 1 here has a video management platform which supports big video. So this whole dynamic growth of mobile data traffic, with telecommunications, AT&T, it's streaming data. Just looking at these 4 graphs on the bottom here, it just shows the traffic evolution. The one on the left here is the United Kingdom alone, mobile data traffic growth, and it's just going to go, up and up even more. And so that it just emphasizes the need for big data techniques to handle this type of data, and so forth. And we can categorize the data traffic that's found in different types of data traffic consumption in Europe according to the different categories and so forth. So this whole thing of big data, it's just getting bigger and bigger. It involves storage, cloud support, analyze, mobile processing, terabytes, compression, NoSQL. Big data and cloud computing equals question mark. It's just, where are we going from here? Because, data is just going to accumulate more and more. And this variety, velocity, and so forth. What's the future of this? How are we going to be able to handle this in the future? And so this interface of big data, security, and cloud, how's big data, can interface with the cloud, telecommunications, and we want to have secure data. And so this security issue of big data in the cloud, that's, many challenges of that was forthcoming. The first chapter of the book talks about the top 500 supercomputers, which is updated every 6 months. And this is the listing from the listing of June 2018, which shows the top 500 big data storage servers list statistics by application area. And if you note that the the most frequent application area is not specified, which indicates the diversification of the applications of big data. It's not necessarily for defense, aerospace, or energy. It's for, it's not specified. It's for multidisciplinary areas, applications. And just looking at this, just the number of gigaflops there, that's one with 9 zeros at there. That's 96.6% of the share, and that's 45 million cores, over 45 million cores of data that's used. So, how do we visualize data? Half of the book is on big data storage. The other half is on big data visualization. How can we do that? Okay, so the Hadoop distributed file system uses something called MapReduce. It sort of breaks up this big data into smaller documents, as shown in this figure here. And these documents can have multifaceted types of data. Is it text data? Is it numerical? Is it symbols? Or is it other? And so MapReduce breaks this up into smaller components and breaks it up into different computers. And you can allocate one computer to do numerical work, one computer to do the text work, one computer to do other, and so forth to get this result. So you can shuffle the data and reduce the data. And so there's a lot of different ways we can visualize data. Here we have a tree map, which here we have different tiles here, which are different sizes and color to demonstrate the data. And this has to do with population of the state. The color represents the number of vehicle accidents, fatal injuries per person. So the darker color corresponds to a higher number of fatal injuries per person. And so the size of the tile indicates the number, and the darker color indicates the higher number. Okay, here we have a sunburst graph, which has concentric circles here. And you notice that the outer concentric circle has more slices in it, which indicates that we have more types of data that we can put in there. So the middle one has to do with male and female, and then the next one talks about U.S. highways, country roads, state highway, and so forth. And then the outer one breaks it up into more intricate type of detailed data classifications. So this is another visualization technique. Here we have parallel coordinate graphs. Some of the graphs are dashed lines, some are dots, and so forth, but they're all interfaced on top of each other. And this has to show the number of fatal injuries by age group and route. But then we also can have circle packing graphs. And we notice that the largest circle there is South Atlantic, which has 8,408. And it's color-coded to be in the south. You can see that little key in the right bottom there, South, Midwest, West, and Northeast. So the one that's white there, Mid-Atlantic, 2883. There's the one there is rather small. So, but anyways, the size of the circle and the color of the circle is another way of showing visualization of big data. Here we have examples of heat map graphs, and these and this is not in color, but I'm just saying, if you saw the color intensity indicates the number of fatal injuries by state. And I've done a lot of work in bioinformatics, and heat maps graphs are also used in microarray sequencing. And you can see the intensity of the data for microarray data, which is very intense data. Next one here is examples of streaming graph data. Here we have layers, which are color coded by region, and the number of fatal injuries in the United States by region. And this is continuously, streaming data is continuously changing data. Okay, so there's many big data visualization techniques. Here's a table of just a few of these here. And you notice that the left column 1 to 9 are JavaScript based, and 10 through 18 are user interface based. And so the JavaScript based include Fusion charts, high charts, digraphs, leaflets, Google charts, raw charts, etc. And the user interface charts include Tableau, Data Wrapper, Power View, etc. And these are the websites for these. And I can go on and on, but this is just an overview of different visualization techniques. And so this whole thing with big data transactions, interactions, and observations, it's just getting bigger and bigger, and increasing data variety and complexity, just go on and on. I teach a data mining class every other fall. And in last fall, I actually did data mining of big data. And in my classroom, I used SAS Visual Analytics and SAS Visual Statistics, where we actually used 3 million rows of data from the Teradata University network. And like 2 or 3 years ago, I wouldn't even think of being able to do this in my class. I'm telling my students to analyze 3 million rows of data that's on a server somewhere else using visual analytics. And SAS has taken the lead in generating software for that very recently. Okay, so here we have a comparison of data characteristics by industry. On the left-hand side here, we have volume of data, velocity of data, and variety of data. It's color-coded. Red is very hot, and blue, dark blue, is very low. And you'll see that very hot compared to the other industries. Banking and securities, the volume of the data is very hot. Commercializations, media, and services is very hot. Government is very hot. Manufacturing and natural resources is very hot. But things such as moderate in retail and transportation and utilities for a variety of the data. So, this shows the color coding of the hotness of the data characteristics for the different types of industries. And on my next slide here, I extended this table on the bottom here to show hardware, software, and services. And what it's telling us that hardware is very hot for communications, media, and services, very hot for government, but not so hot for wholesale trading and so forth. And very low is for services in education and so forth. So there's a big potential for applications of big data and things that haven't been done so far. Okay, so this vertical industry growth by technology over the next 5 years, it just shows that in mobility, telecommunications, it's just going to expand mainstream and so forth. Big data and business intelligence in the next 5 years. Cloud applications of these, financial services, government, healthcare, insurance, manufacturing, retail, wholesale, and so forth. And so this big data visuals toolbox, this volume, velocity, variety, and veracity is just going to get bigger and bigger. And as far as data sizes, 4Vs, cloud, and so forth. And software as a service, the cloud, this triangle on the right here, it's just this interface between big data and software as a service in the cloud applications. Technologies are going to get bigger and bigger. And like in this Hadoop architecture, we have a MapReduce layer and the Hadoop distributed file system layer on the bottom there, where we break up the data into a job tracker and a task tracker. And in the HDFS layer, we have name node and data node and so forth. And this MapReduce workflow in the Hadoop file system breaks up this input domain into different maps. A MapReduce job usually splits the input data set into independent chunks which are processed by the map task in a completely parallel manner. The framework sorts the outputs of the maps, which are then inputs of the reduced tasks. The framework takes care of scheduling tasks, monitoring them, and re-executes the failed task. Okay, so this Hadoop ecosystem uses this whole interface here of extract, transform, and load tools, business intelligence reporting, relational database management system, interfaces with Zookeeper, Pig, Hive, SQL, all these types of software, and the MapReduce job sequencing execution system, the Hadoop distributed file system, interfaces with all of these available tools and so forth in big data. And this Hadoop distributed file system, the large files are split up into parts. It moves on the bottom there. We see that 1 to 5 data broken up into different parts and different clusters and so forth. And it's fault tolerant through replication across nodes while being rack aware. So plus the bookkeeping via the name node. And so by MapReduce, we also move algorithms closer to data by structuring them for parallel execution so that each task works on part of the data. Power of simplicity via maps and reduce phase. So we have different algorithms that we can apply depending on what type of commodity we're doing with genomics or doing with retail data or whatever. And so this real-time big data processing, this data streaming, we're using transactional data, operational data, social data, machine-to-machine data, cloud service data, the operational systems, the business analytics of this whole thing, shared data, and so forth. Universities are offering degrees in data science and visual analytics and so forth. It's just a whole, it's the state of the art right now. So we can talk about parallel processing of transactional. We can do all these processing in real time and parallel processing of these transactional, analytical, operational, and archive systems. Okay, so my webinar today was in hopes of bringing an overview of what big data is and how we visualize it and how do we store it. And what I want to convey is that my 2-volume handbook of big data storage and visualization techniques, here we have a flow chart of the chapters in the book and how these interface. I talked about what is big data visualization, big data storage today, which is in the top here, chapters 1 to 2. But we also talk about storage methods, cloud clusters and grids in chapters 6 to 8. On chapters 3 to 5, we talked about big data databases, database systems, Hadoop, open source software. Chapters 9 to 12 talk about big data processing for storage and visualization, programming and pre-processing, high performance storage, massive parallel processing, distributed stream processing. Chapters 13 to 16 talk about data warehouse architecture, big data processing, big data access, big data storage, and big data analysis. And chapter 17 to 23 talk about visualization tools and techniques, big data visualization tools, overview big data image processing, big data statistical visualization, computer graphics for big data, predictive modeling for big data, Internet of Things for big data, multimodal big data. Chapters 24 to 30 talked about applications of big data visualizations of visual analytics, linguistics, visualization of genomics, actually big data for performing arts. How is big data used in dance? How is big data used in philosophical perspectives? How is it used in stock exchange? How is it used in quantitative chemical analysis and so forth? So I hope I've been able to give you an overview of how big data affects you and look into the technological processes that drives everyone's decisions, and also an overview of the topics in this very intense updated handbook of big data storage and visualization techniques. And I carry this presentation over back to Charlene, who's going to talk further.
Okay. All right. Okay, so now at this time, if you have any questions for Dr. Richard Segal, we'll ask you to please type them in using the chat feature in the GoToWebinar toolbar. For those who have questions after the session, my contact information and Dr. Segal's contact information will be at the end of the presentation. So now we can just proceed to the questions. And I understand we have a few. So, Dr. Segal. Yes. Okay, so we had this question: when is data considered big data when it comes to analysis?
Well, I can't. It's difficult to quantify a number on that. I'm just saying that when we're talking about millions of rows of data, that's big data for sure. And in my traditional database management class, we can't use. If you have a million rows of data, how can you make how can you accurately, concisely use, draw diagrams, entity relationship diagrams for a million rows of data, and, for all the entities that you have? It's just, it's pretty infeasible to do. So I'm not, I can't say I can hang a specific number on it. I'm just saying that when, when you have a pretty good feel of dimensionality of data, whatever this process is, you're doing manufacturing, you're doing genomics, you know that you have an application for big data.
Okay. So we had another one that said, what are the main research topics in the big data field, especially when it comes to cloud and virtualization?
Well, as I said, I had a slide there which shows for were the applications for the top 500, and the number one category was not specified to be anything. It's so diversified. It was not one. It wasn't used for defense purposes. It wasn't used for aerospace. There was a slide there that had that. It's just that it's pretty much diversification of different areas. But I'm just saying, right off the bat, telecommunications, data streaming, it's got to be in the cloud. And, that's one of the prime areas there. And I think we're talking about what specific applications. What does Amazon.com do? I mean, how many items are available from Amazon.com? I mean, they've run out of room for their warehouse if they actually had to build. They're talking about having 2 more warehouses. One's in New York City, and the other one's in Northern Virginia. There's only one Amazon.com. There aren't other competitors to that. So I'm just saying that that's an example of retail applications for big data. But I can't pinpoint it saying number one application is so and so. But telecommunications, Amazon.com, in healthcare delivery. Data is just continuously, all the experiments that the FDA has to conduct all the time, and National Institute of Health, patient data. It's getting bigger and bigger every day. And as I said, one of my slides is that how much new data is being created in 30 seconds around the world. Intensifying.
I see. Okay, thank you. So another question we got was, it said, what about ethical issues with big data? So I'm just going to ask you, what are some of the main ethical issues in big data, in the big data industry that you see coming up?
Okay, well, one of my slides had that triangle there with security. How do you keep big data secure? I mean, that's an issue. Credit card companies have big data. Data is getting bigger and bigger. One of the biggest challenges is, in addition to visualizing and storage, is how can we maintain our data to be secure? That people aren't doing something with the data that shouldn't be accessible to, and confidentiality of data.
I see.
That's an issue. Just magnifying that issue. I mean, security is an issue for regular data, but big data, it just intensifies it even more. So, so that's a major ethical issue. And another ethical issue is that with the security of people tampering with the data, and that creates other problems. And so.
Okay. We had another question. What is the best software to use in teaching students how to analyze big data?
Okay, well, as I said in my data mining class, data mining here for about 10 years, started using SAS Enterprise Miner, and but that was SAS Enterprise Miner was developed around 1980 something, and now that big data has evolved, they had to, I guess, SAS thought, how do we deal with big data? And Now we can actually analyze big data on mobile devices with SAS Visual Analytics and SAS Visual Statistics. You can actually do big data analysis on a tablet, and you could not do that with SAS Enterprise Miner. And they actually, SAS also has workshops. If you're a faculty member, they give summer classes, which they don't charge you for the workshops, to show how to use their software. And they've actually come out with, is it VIA, VIYA, which just came out within the last 12 months, which integrates together, instead of me going to the Teradata University Network, TUN, to get the big data, it has it all integrated together. This just happened. I took a workshop last summer at SAS headquarters. But there's also Tableau. Tableau is doing a lot of things with visualization of big data. So those are the two really big softwares that I've used. But you answered your question, for teaching a class, that's a lot different than if I'm doing research by myself or something. For teaching a class, I would recommend either SAS Visual Analytics, which includes SAS Visual Statistics. It's sort of built into it, and also Tableau. Those are the two that I would recommend. And there's training sessions for SAS, and they have the SAS books for it already out for that. And VIA just came out within the last 12 months, and I took a workshop last summer, and I don't know if they got the books out for it yet, but it should be out within next near future here for sure. And Tableau also, I think, has you can get free demonstration versions of Tableau, which you can download. And I've actually had a couple of hands-on sessions with the people at Tableau, so they could tell me how to use it for my class. They were very, very cordial to me integrating that into my teaching.
All right. Okay, so that concludes our question session. So thank you everyone, and Dr. Segal, and thank you for the questions as well as the wonderful discussion. For those of you who are interested in continuing the conversation, please feel free to email communications@igi-global.com or Dr. Segal with any additional questions, and our contact information will be at the end. Additionally, for those who are interested in more information around this topic, please be sure to check out the recommended publications. Our presenters' research, along with thousands of other resources, are available in print and electronic format on IGI Global's online bookstore. Those who order directly from IGI Global through our online bookstore will receive a 20% discount. I would also like to draw attention to Dr. Segal and Mr. Jeffrey's contribution to IGI Global. We are extending a 50% discount on this publication as for all of those who attended. There will be a follow-up email on how to access this discount, so I encourage you to check your inboxes. So all of IGI Global's publications and research are available as part of IGI Global's InfoSci database collection, which includes InfoSci books, a collection of over 4,500 books containing over 89,000 chapters, and InfoSci journals, a collection of over 175 journals with over 24,000 articles, with over 1 million citation references, and specialized and subject and discipline-focused databases. Currently, IGI Global unveiled new pricing for all of these databases. As part of these new pricing, IGI Global is offering InfoSci journals. We are offering an annual subscription price for as low as $4,080 for new customers. For any library that invests in an IGI Global journal database, IGI Global will match the library's investment with a fund of equal value to go towards subsidizing the open access article processing charge for their students, faculty, and staff at the institution when their work is submitted and accepted under open access into an IGI Global journal housed within that collection. This is to ensure that the researchers not only have access to the quality content they need, but it will also provide an affordable way for them to publish under a quality open access offset model program. Please refer to the webpage for more details and recommend this database to your library to take advantage of this offer. Additionally, I understand we have some library customers. So IGI Global offers an extra 5% when you sign up for a free IGI Global library account. Just visit igi-global.com/library-account-program. be sure to check it out. And we will be sending this recording, and you'll be able to view all the necessary details. Once again, I would like to thank everyone for their time, and for those who are interested in learning more about IGI Global, please visit our website, www.igi-global.com, and be sure to visit our published webpage to learn about the publishing opportunities we offer. We are seeking proposals for new subjects projects in our 11 subject areas. Again, our presentation has been recorded and will be sent to all attendees, and as a thank you, we will be offering you a 50% discount on Dr. Segal's and Mr. Cook's contributed publication and the recommended publications that are listed. Be sure to check your inboxes for the special discount code. I hope you will join us for upcoming webinars, and for any questions, please feel free to contact me at communications@igi-global.com. Thank you once again for joining us. And to you, Dr. Segal, I hope you have a wonderful day.
Thank you.
Yep.
Thank you for all for participating.